So why do we do all this stuff? Well, one of the things I like about our lab and the work that we do is everything is applied. And by application, I mean what we collect and what we analyze is actually used in the assessment framework and the management frameworks. So things like age and growth, for example, how old is this fish and how long is this fish are really important when you calculate your numbers of fish at age, your weight at age, your maturity at age, at what point should you start to kill the fish or harvest the fish so that you make sure they have a chance to reproduce. And what we do, as you've seen a million times, we take these otoliths out of the fish. There's a whole process that we follow in terms of standardizing this, where we clean these things, we photograph them, we weigh them, we section them, and basically what we're doing is nothing different than you would do for a tree. So just like dendrochronology, you go in your backyard, you cut a tree down. If you were to sand that stump down, maybe put some sort of a contrast agent on it, like a varnish or even waterworks, you would be able to see the rings. Well, similar to the rings of the tree, the otoliths also grow with what we call different rates of accretion. So these otoliths are small calcium carbonate crystals in the backs of the skull, and they grow according to the metabolism of the fish. So in the summer they're growing faster, in the winter they're growing slower, and that difference in density or difference in rate of accretion shows up as alternating bands of different clarity. You have what are called opaque bands and then translucent bands. And if you look at, I know it's hard, this is a little bit like a Rorschach painting, but if you look at actually over here, hopefully you can see my pointer. But if you look over here, we don't count this part of the otolith. It's not as reliable. But if you look here, you can see that there's a little bit darker blue, a little bit lighter blue, a little bit darker blue, a little bit lighter, a little bit darker. Now, each one of those represents approximately 6 months. So you don't count one blue, one dark blue, and one light blue. You just count one of them. So we have protocols set up where we all count the same ring, and you start sort of back here at the center of the otolith, and you count your way out. And so this one was a fish that we collected a few years ago that was 31 years old. And this one up here is from some colleagues in the Gulf of St. Lawrence in Canada, and that one was 35 years old. So these otoliths are accreting material every day, excuse me, and the rate of accretion changes seasonally, and that's why you get those contrasts, because you have what equates to a summer band and then what it would equate to sort of a winter band, and you use those alternating bands to basically establish or estimate what an age is. And we've done validation studies on these, and so other not our lab but other people before our lab validated that each one of these increments does in fact represent approximately a year. Two of those bands is approximately 1 year. And so once you have that validated, then you can estimate them with more confidence. You can say, yep, every one of those red dots is 1 year of the fish's life.